Okay, so we're going to go over the constructing spinners activity. It's based on the concept of geometric probability. Geometric probability basically means that based on the size of the potential outcomes, I can predict what portion of outcomes will land where. So for example, if I have a spinner and my spinner is equally divided into 4 different sections. Let's say this is red, green, yellow, and blue. They're color coded. Well, looking at my spinner, it seems that I am equally likely to land on any of the 4 colors. If I change that spinner, however, so that half of the space is blue, well, I should be twice as likely to land in that blue area because that area is twice as big. So geometric probability is basically just comparing the area. You're given 3 different spinner outcomes in this packet and told to explain your reasoning for how each of them could come out. The chart you're given is the result set for what happened with that spinner. Now, your reasoning may not be the same as my reasoning at all, but you end up with the same result. If I look at the outcomes for spinner A has 3 different sections, 1, 2, and 3. And I see that I have way more times I landed, and X represents I landed there. So I landed in section 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. I landed in section 2 5 times. So I could keep a total over here. I've got 10, 5, and 5 as the number of times I landed in each section. Well, if I can assume a geometric probability, then I think that my spinner A is probably going to be that section for 1 should be twice as big as the other 2. And not only that, but if I add the total number of spins that landed in 2 and 3, I see that that sum is equal to the number that landed in section 1. So when I come over here to one of my circles and I draw it to represent spinner A, I'm going to say, you know what? I think that half my area needs to be represented by 1. And then the other half of the area should be equally divided between 2 and 3. So that is my representation for spinner A and why I chose to do it that way. Okay, if you did that, you got this as your spinner for A, whether your reasoning is a little different or not, great. Go ahead and check spinners B and C. If you didn't get this and you kind of had an aha moment, stop, draw new circles for B and C, and try them again before you continue with the video. Okay. So let's take a look at what spinner B should look like. Well, let me just show you mine first, and then I will tell you my reasoning. This is what I got for spinner B. When you look at my spinner, you can see that I actually constructed it by drawing a line here and then erasing it, so that my spinner started out by being divided into 8 equal sectors. 1, 2, 3, 4, 5, 6, 7, 8 equal sectors. And then I made it so that my sector for 1 included 2 eighths and my sector for 4 included 2 eighths. Another way to think about it is that the combined outcomes in 2 and 3 are the same number as the combined outcomes in 5 and 6, also the same number as outcomes in 1 and the outcomes in 4. So here is how I decided how to divide up my spinner. When I looked at my table for B, automatically I saw things in groups of 3. You see you have 3 here, 3 there. Then I've got 3s going all the way down and another second set of 3 for number 4. When I started counting my sets of 3, 1, 2, 3, 4, 5, 6, 7, 8. I see that I have 8 sets of 3 outcomes. So that's how I decided to divide my spinner into 8 equal sectors. And then out of those 8 equal sectors, I assigned 2 of them to 1, 2 of them to 4, and 1 each to 2, 3, 5, and 6. I know students that look at this a lot of different ways. Some students see that if you take 1, 2, and 3, that's half the outcomes. 4, 5, and 6 are the other half, and then they divide it up inside from that. Some students go completely algebraically. They add up the total number and then get a percentage over here and draw their spinner according to that reasoning. Just make sure that you have a reasoning for why you did it. Again, I'm going to give you one more chance. If you don't think you got spinner C right based on what we talked about, stop, draw you just a new circle. There's nothing magic about the circles I gave you. See what spinner C should look like according to what you've drawn, and then start the video again. Okay, here's my spinner C. In my spinner C, this one was a little trickier. This one's a little more awkward. I started out by dividing my spinner into 10 as equal as I could get them sections. So I divided it in half, and then I said I divided each half into 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 different areas. And then I figured out how many of those 10 belonged in each numbered sector 1, 2, 3, 4, and 5. So let's look at our outcomes. I saw 3s again. I'm not sure why I see 3s. I know that not everybody does that because I listen to you guys in class each semester, and there's at least 2 or 3 different ways to approach this. So do not be concerned at all if you didn't approach it the way I did. If you got the same outcome, you did great, whatever your reasoning was. But I saw groups of 3. I saw that I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 groups of 3. So I divided my circle into 10 equal sectors. I assigned 2 of them to 1, 2 of them to 3, and 2 of them to 5. Just one of those tenths to 2, and 3 of them, 4 got 1, 2, 3 sets of 4. So 4 got 3 tenths of it. So, okay, sorry, wrong circle. Here we go. So you can kind of see there where I had my lines drawn, and I said, okay, 2 tenths of it is assigned to 1, 2 just gets 1 sector. I need 2 tenths of it assigned to 3, and 1, 2, 3 of them assigned to 4. That's my biggest sector. And then 5. 1, 3, and 5 should be geometrically the same area. 2 should be half of each of those. And 4 should be the biggest. 4 should be the same size as 2 and 3 combined, which is what I was going for. It wasn't perfect. The important part is the reasoning. Were you able to reason it out?